All right, so I think this is recording. Let's take a look at problems 4 through 7. We want to determine if the relation that's given is a one-to-one function. So first we need to determine if it's a function. If we look at problem number 4, remember that we had some general rules of thumbs about the variable y. First, if we look at the equation and if we see a plus or minus symbol in it, it fails to be a function. So therefore, it would not be a one-to-one function. If we look and if we see absolute value symbols around the y, it would fail to be a function. And if it fails to be a function, it fails to be a one-to-one function. If we see an even exponent on y, that would lead, when you solve for y, that would lead to a plus or minus symbol, and it would fail to be a function. So it looks like when we look at this variable y in problem number 4, it's an odd exponent. You could solve this for y and then take the, solve for y cubed and then take the cube root of each side, and you would get an expression for y. Is the function a one-to-one function? Well, since in finding the equation for an inverse, you switch the domain and range, the general rules of thumb that we used applied to the y variable to determine if it was a function, we can apply those same rules to the x variable to see if it's a one-to-one function, because what we'll do to this equation is switch x and y. Well, once you switch x and y, you look at y and see, you can determine through the equation if it's a function or not. So when I look here at x, I don't see absolute value symbols around it. I don't see an even exponent, that x is to the first power. So not only is this a function, but it is a one-to-one function. If you took some time to construct a table, plug in a few points, and plotted the points, connect the dots, you would see that this is a one-to-one function. But like I said, I don't necessarily have to graph it. If I see that there's no absolute value symbols around the x, there's the exponent on x is an odd number. What I have here is a one-to-one function. So when I look at problem number 5, is it a function? Well, yes, it's an absolute value function. When I look at that variable y, I don't see absolute values of symbols around the y. I don't see an even exponent on y. It's y to the first power. This guy is definitely a function. Now, if you apply those same ideas to the x variable, because see, when we switch x and y, you're going to have an absolute value symbol around the y. So this is not, it's only the functions that are one-to-one have inverses that are also functions. The inverse of this absolute value function is a relation and not a function. It is not a one-to-one function. And I know that because the absolute value symbols around the x makes it look like a V that opens upward, and that fails the horizontal line test. It is not one-to-one. Now, when I look at problem number 6, the equation is just a line. You have x to the first power, you have y to the first power. I don't see any plus or minus symbols in there. I don't see absolute values around either variable. So yes, this is a function. In fact, you could solve it for y. It's a linear function, and it's not. It's the only linear function, the only line that I'm concerned about being a function is a vertical line. Now, if I had a horizontal line, yes, that's a function, but it fails the horizontal line test, and it would not be a one-to-one function. But this is going to have some non-zero slope. This is definitely a one-to-one function. When we look at problem number 7, we see that there's an even exponent on the variable. Well, first we determine that it is a function, that there's no plus or minus symbols in the equation. There's no absolute value symbols around y. Y is being raised to an odd power. It's y to the first power. We're familiar with this function. It's a quadratic function. The graph of this would be a parabola that opens downward because of that negative. Well, being a parabola, yes, it passed the vertical line test, but it fails the horizontal line test. This is not a one-to-one function. And like I said, when you come in to find the inverse, when you switch x and y, then we know this inverse is not a function, because we have this variable y raised to an even exponent. Eventually, when you get y by itself, it's going to lead to a plus or minus symbol. So the same rules that we use to determine if it's a function, if we apply that to x, we can determine if it's a one-to-one function. Since x has an even exponent, it is not a one-to-one function. It would fail that horizontal line test. All right, well, I hope that was clear. I hope I explained it well enough. If you have questions, don't be afraid to ask. But in combination of just knowing some general rules of thumb, in combination with knowing the general shape of the graph, you should easily be able to answer these. All right, talk to you later. Bye.